Hopkins and North Carolina, and then eventually she ended up as a faculty in Harvard. Then I said, you have to distinguish yourself when you make an application. And she did by various science competitions, dance performances, things like that some time ago. Then they said, what's the new idea that I said that if you really, really want to get into science, try to understand how Nobel laureates got into science. Because earlier I published a book, abridged and published a book on scientists greater than Einstein. And the book contains 10 scientists whose contributions Carl Landsteiner kind of people who contributed to the welfare of all the patients or people. And millions of lives were saved with their work. And one, Billy Woodward in Kansas, he's not a friend of mine, but when he was struck down with some severe problem, one simple medicine, allopurinol, gave him relief. Then he thought that scientist must be greater than Einstein. So he boldly named the book as Scientist Greater Than Einstein. When I read that on a flight, non-stop, 400 pages to India, I was surprised at how all these things were not in the brains of the students or public. So I told Billy Woodward, that's a very big, long book. Instead, I'll make it into 200 pages. So he said yes. Then at the same time, I talked to some people who were alive, and they also said, okay, do it. Then I did that. That was the background, but not as actually pursuing that as a line of activity. But now, I told this girl that do it, and she did immediately take up. But then we can't publish a single chapter anywhere because there's not much of novelty in it. Then I said, don't worry, with my money, I'll publish a book. But you have to get another dozen students or so, not just one or two students. Then she worked and we worked in my circle, everybody's connections. 14 students finally came around to write this. But I put a one condition. You cannot simply do Google search and finish it. You somehow have to contact them, send your questions, get your answers, think about it, reflect on those answers, and then write the chapter. This is pre-ChatGPT time. So that's how we got it. Then these students, again, they want to write for the second edition. I didn't have any plans to make the second edition, but they said that, why don't you do another edition? There are so many Nobel laureates we would like to explore. I said, okay, we'll do it. Now we are going to do it in chemistry, physics, and maths, though it's not exactly Nobel, but it's a field matter than things like that.
So, this all sounds very nice. It was fun to be interviewed. I worry about one thing, and that worry is that the world does enough of putting Nobel laureates on a pedestal. We do enough of it. It's not the road to success. It's not, and you even said that in this book that you wrote, different criteria for what has been accomplished. I myself have a very probably slightly different take on what the Nobels are. I think that they're not prizes to the best scientists. They're not they're not to the people that have the biggest labs or produce the most papers or publish in the, they are in many cases awarded to work that change science or how we think about science. And as I read many of those papers, many of the biographical sketches that are there are a surprising number of these people that were doing one thing and noticed something else. They weren't trying to answer a question. They weren't trying to succeed as some people were. Some people were very directed at trying to answer questions. Watson and Crick. But there were many others that were working and suddenly realized something else. And it is, I think, rather remarkable how many times you will read in the biographies statements of, I was working on X and suddenly Y was there, or I wasn't thinking about this and then all of a sudden this happened. There's a couple of rather famous examples of this, or at least I feel that they should be more famous. GFP is one of them. GFP was discovered by
and you connected them.
Was done by complete accident, and there was no imagining that there were proteins that were fluorescent. It wasn't on people's radars that such things could exist, and Shimomura found it by accident, or by thinking about what he was working on, realizing that that's what he had. But it wasn't sort of directed. So the idea of how do you go about, it's not how do you go about getting a Nobel Prize, because a Nobel Prize comes for many people by accident. That's not it. So what I would find is a fascinating book. If you want another book for them to write, it could start with Nobel laureates, but have the Nobel laureates in there, ask them, who is someone in your department that you really respect that doesn't have a Nobel,
yes,
that isn't doing it? Why what they do excites you? People see, all of a sudden people every year go from this sort of non-magic situation of not being a Nobel laureate to suddenly, oh my God, they're a Nobel laureate, how wonderful, they must have been great. But no one recognized them beforehand,
yes,
or they didn't. So it's a little bit silly. It's a little bit ridiculous to me. So it might be more interesting to have, and much harder for students,
yes,
to go off and find the people, not who should get a Nobel. That's not what I think. I think that's not the right way of doing it. But to go off and find out, what are other people doing? Why is that interesting? Why is it exciting? What are they? Because I think we go the wrong direction. The direction is, some group in Sweden gave this person a medal. They must be important. Let's find out what they did. They must have done something important. It's the wrong way around. It's sort of like saying, this person has the seal of approval. We better go find out what they did. And then I'll give you, as I think I may have told the students, since I say this a lot, I'm going to prove to you why Nobel laureates have absolutely no clue as to what. All right? I'm going to prove it. I think I have very, very good proof. The ceremony in Stockholm is wonderful. Everybody likes it. Everybody likes the recognition. It's an entire country that decides it's going to celebrate academic achievement. Right? Where does that happen in the world? Nowhere. And you get treated very, very nicely. I doubt that there is a single person that goes through it that says, oh, that was boring. I don't like that. They all, I'm sure, go through it and say, wow, I would really like to do that again. That was fun. That was really nice. My ego is really boosted. This is wonderful. But they don't. There's no secret to how to get a Nobel. If they knew it, we'd all be getting, if we knew it, we'd all be getting our second and third and fourth just to be able to do it. But we don't. And that says we don't know.
You're proving it.
We absolutely don't know. So I'm sorry to be so argumentative, but it seems to me that telling students about Nobel laureates is maybe not the best way to do it. I have a friend over here at Teachers College, which is connected with Columbia, who was teaching a very interesting, or was doing a very interesting study. And I think it was grade school kids, and it was grade school science, and how well they did on the material. And in talking with having the teachers and going through it, they had two groups, identical lessons, the usual sort of test case. And the first case was teaching a lesson. And part of that lesson in science, or some semester in science, was to talk about the great people that have done wonderful discoveries. And the second version of the course was exactly the same as the first, except for one additional thing. There were discussions about how these great people had failed and what they had done incorrectly, that they were not these sort of godlike figures that always got everything right. There were things they got horribly wrong. And then when the exams came through, the students in the class that heard about failure did better than the ones that just heard about the great achievements. I think in part it sort of says, the first one, I'm going to interpret this, I don't know if this is actually true or not, but I think the first one says, here's this unattainable goal.
Yeah.
This is this impossible thing that's what you should strive for. And that, I think, is wrong. The other says, they made a lot of mistakes. They were stupider than you in doing this, and yet they were able to, push through, or they were able to luck out in doing this. And I'm sort of taken by that idea that maybe, we might have the wrong end of the stick. That instead of putting up these idols for people to learn from, maybe it should go the other way. There's this wonderful event that occurs just after the Nobel ceremonies are finished. It's on the ceremonies go from the 6th to the 12th of December. On the 13th is Santa Lucia Day. There's a big celebration. There's a lot of singing and everything, and they have banquets. And if you stay over that next day, there's a banquet for the chemistry laureates. There's a banquet for the medicine physiology prize people. There's one for the physicists, and so on. And these Santa Lucia balls are quite wonderful. There's a lot of fun. There's a lot of drinking. It's a good time. And but one of the wonderful things for that the students and faculty at the Karolinska, which that's the medical school that gives the medicine physiology prize, they use that as their big award ceremony. And when they give people awards, including the laureates, they sing this song in English, which I'm not going to sing for you, but I may not remember all the words. It's very short. It's oh, why was they born so beautiful? Oh, why was they born at all? They're no bloody use to anyone. They're no bloody use use at all. In other words, they start out wonderful and then they put them right down to where they're supposed to be, and then they go off the stage, and that's it. And I quite like that. Okay, calm down. Don't. So, it was fun doing this. It's always nice talking to students. I know I'm sort of whistling in the wind to say people should start ignoring Nobel laureates, but that's what happens. Excuse me for a second.
Yeah.
So that's a USB drive.
Yes.
Great. I will plug it in and be
Okay.
able to work. Thank you.
Good.
Take care of. That's going to replace my coffee stained,
Oh, because of-
ruined keyboard that I.
Sure. My purpose of coming to meet you is, yes, I can thank you email because you already have helped a student, but I thought that we are in here, and
Well,
why not meet?
this is very nice. I appreciate it.
And-
Thank you.
Yeah, and the other day I was with the past president of American Heart. We were just chatting, not any
Mhm.
specific subject. He is down in the Manhattan, Fifth Avenue, in their office buildings. They have a full floor, American Heart.
No, I
And he
I
said,
didn't realize that.
yeah, I just casually, he asked me, what else do you do? Because he is now chief of Food is Medicine program. Food is Medicine.
Uh-huh.
It's a big program that they have $14 million from Rockefellers to make sure that people understand food is medicine. So in that context, I met him because I invited him to speak. So he spoke, and then subsequently we said that we should meet leisurely. During that conversation, there is a word about this book. Then he said, did you cover Dr. Martin Chalfie? Yes, we did. Oh, the other day he was passing by. I told my wife, see, the Nobel laureate is walking.
I'm not sure. What's this person's name?
Mitchell Elkin. I can send a common mail.
That's fine. That's fine.
Mitchell Elkin. He's a neurology professor. Maybe it will be interesting to you because you are going into that area, neurology by neurosciences, right? He's a neurology professor at Columbia, and took a leave of absence or some kind of arrangement to go to American Heart. He was the ex-president, and now he's heading a big program. So that's yeah.
This is my daughter, so I always have to answer that.
Oh, me too.
Hi, so can I call you back in a little bit? Yeah, but I'm in the middle of talking to somebody right now. Okay, I'll call you back as soon as we finish. Okay, bye.
We'll make it fast. I don't want to meet.
That is, no.
So
I'm sorry. So what do you do other than helping people publish books?
no, this is. I'm a scientist. Actually, the earlier idea that you were saying, that what mistakes people did
Mm-hmm.
and how it could not be a big thing. My case is a very classic case. Ubiquitin
Mm-hmm.
is what I started. I did not wanted to go into research or anything, but it just so happened my supervisor said that you don't know any science because I didn't do any molecular biology at that time. But I'm a molecular biologist. This was in India, Center for Cellular and Molecular Biology. And we are into molecular biology in cells, and you never did anything in that. Yes, sir, I did not do anything. But you were selected in the top at Indian Institute of Sciences, Bangalore. How did you do that? I said, the chairman asked me to come for a test, and I told him the same thing, that I did not read anything about cell biology, molecular biology. Then he said that, okay, Leninger, Molecular Biology by Watson, take these 2 books, read and come back within a month. First edition of Molecular Biology of G.
Mm-hmm.
So Leninger was also completely a new book for me because I never did any biochemistry. Obviously within a month I sat and read, and I had a full freedom to ask any question because the chairman said anybody in the department can answer to me. And I did very well there. And so is the case with other institutes. So he said, oh, if that is the case, we don't need you to give any project. You decide what you want to work on. Come up with 3 projects and we'll select one. Do a good presentation after 3 months. I said, okay. one of the projects is the ubiquitin. At that time, in 81, it is known that ubiquitin Goldberg has published a big review, annual review of biochemistry. He said, this molecule is necessary for recycling of all the proteins that are not useful for the cell. So ubiquitin, unless it binds to any protein, that protein cannot be degraded. But for that to get degraded, there must be an enzyme. Ubiquitin cannot do it. Ubiquitin is only a 90 amino acid short chain. Then I said that, okay, let me purify the enzyme. There is not a single mention about that enzyme at that time. And that's a very simple biochemistry, to purify columns and all those HPLCs. So I did that, and I got the single band. I got the activity. But when I get the single band, I don't get the activity. So I did that for 1 full year. And I told Dr. Bhargava, PM Bhargava, he's my supervisor, Dr. Bhargava, let's publish that we have an enzyme, active fraction, because I see so many people publishing the fractions, not pure enzymes. He said, no, that is below my prestige to publish a single, unless it is pure. So I kept on doing it, and everybody in the lab said that you are at a dead end, leave the lab. So I had to leave the lab. And I left the lab 2 years after. Eshko from Israel, Weizmann Institute, he's a Nobel laureate. He published that you need an RNA component. You cannot have a pure protein as an enzyme to work to degrade that. That's the kind of lock and key mechanism. Of course, by then I got a fellowship in Paris to do PhD in molecular genetics and sickle cell anemia. So, no regrets, but that's a great point. Had I not gone to Paris, instead had I applied to Weizmann Institute, probably it would have been, at least I would be the company of the people. That was in 84, 85. So at that time, he was also a postdoc.
I see, with Aaron. Yeah.
Yeah. Oh, you know the subject very well.
I know these guys. I've been to several meetings.
Yeah. So that was a great.
I actually knew Fred Goldberg because he had the lab across the hall for me. So
Yeah. This was
familiar
the
with-
best. I'm
yeah.
so happy that, of all the professors that I met in the last several years, you know all 3 of them.
Yeah.
Great. This was in 1980s.
Yeah. I had done my PhD from 72 to 76, 77 across the hall from Fred. So,
His papers were
Yeah,
very
right.
interesting to me because at that time, without knowing any molecular biology, any biochemistry, any cellular events, my simple question is, a medical person, one of our friends' elder brother, who was a doctor by then in US, when he came for vacation, he asked me one question. You are doing biology. He exactly said the same thing. I didn't get into medicine, and she got into medicine. Both were in the same class, but she is a brilliant, and I didn't get it. So he felt bad. She and his brother also got into medicine. He said that, why don't you work on some science topic? The topic is a single cell, a zygote, becomes so big. How does it happen? So I kept on reading books, developmental biology, many things, and all that funneled into one single question: how a single cell, when it breaks down, again builds it. What happens to the proteins? By then, of course, already I have the knowledge about Leninger. So that's where the ubiquitin came into my domain or focus.
interesting. Good. Terrific.
So my purpose of visiting is just to say thank you, number 1. Number 2, this is a wine that I got from Greece. I suppose you drink wine.
I do drink wine. Thank you.
This
Very
is a
unnecessary.
longevity factor. One of the
Yeah.
factors is from.
Oh. Interesting. Thank you. Thank you.
Then 2 more
Oh.
copies, because in case you want to give it to anybody. And the interesting thing about these books, I really wanted to have something special. And this is not just plastic. This is a mirror.
Uh-huh. Yeah. Oh, that comes. Oops. Not my wife.
Thanks, Chef.
Excuse me.
No, we'll
Yeah,
leave it
yeah,
soon.
yeah.
Hi, I'm
Happy
in the
now?
middle of something right now, but Alex came up with
Yes.
a replacement.
No problem.
keyboard for me.
Sir, cut it. Let's close.
Yeah.
Yep. We're gonna have dinner on Saturday? Great. Wonderful. Should be out, go check. I have to check my schedule. I'll do that now. I'll get back to her. Great, okay, I will. Bye. Turns out it was about the same thing.
Yeah.
So,
Do not.
Good.
So it's a mirror. That's good.
Yeah, just to excite people, that's all. That's nothing. And I found one printing company that could do it. So I will take your point very seriously, certainly, and I'll write a mail to you. And I myself have written this whole thing, what I told you, into an article and published on Medium, but they are not much. And every student of mine reads that, and exactly what you said, I will say. You may make 100 mistakes.
You don't have to.
And I said that I made the mistake, and it doesn't mean that you will not make the same mistake, but you can have a chance to not to make that mistake if you read this.
Yeah, except sometimes the mistakes are the best. You know, Shimamura's story is terrific. Shimamura could not work. It could not get the experiment to work. One night he throws the prep away in the sink. And the sink had some seawater, and that had calcium, and that produced light, and so he was able to purify the light-producing molecule, which is his goal. It turned out that was a nice thing, and turned out to be a very useful tool, but it was the wrong color.
Yes.
So the mistakes just kept coming. He made all sorts of mistakes, and I can say that people make mistakes in both directions. They can. There's a wonderful interview with Seymour Benzer, one of the people I would put right up there as one of the real greats in science. Never got a Nobel, did all sorts of amazing things, and Seymour it talks about. Blank out on his name, Max Delbruck.
Oh,
And
that's a
Max
very big-
Delbruck coming up with something called the principle of limited sloppiness. And that is if you're really careful and control everything, you don't learn anything. The accidents don't happen. And the example that he gives is in the early days of growing up bacterial viruses, phage, they would make petri dishes with bacteria on it, put the virus on them, or have the virus incorporated already in the bacteria. And they want to see how much virus was produced overnight. And so they made lots of copies of the plates, put them aside, came back the next day to look at them. And what they found is that some plates had an awful lot, and some plates had very little, even though it was the same amount on each plate. And they realized the plates that had a lot were always the ones on the top of the pile. And those are the ones that the UV from the lamps was hitting. And it was the UV that was it couldn't penetrate deep enough into the pile of plates to activate it. And they were able to make the discovery. So that's what he means by limited sloppiness. They said, well, we have to have these, have them all spread out on a tabletop, and they all have to be in the same position, and they all. If that, they would never have discovered that. The fact that they said, I would just pile them up here. That limited sloppiness gave them so sometimes you need luck. That's it.
Thank you. And if you have the list names, I'll try to find myself names of the people who we should write. I will have another book by another set of students.
I don't
Random.
have your students figure that out. That would be great.
Please
That's-
advise
that's
us,
good.
not only
That's-
this point, but please be an advisor or advise us, whatever. Keep telling.
I'm taking on no new responsibilities. It was fun to talk to the students, but I don't. I go and I talk to students all the time. I just can't take on
Okay.
anybody in particular. Or
And anything about your environmental interests? You already signed a document at the Nobel Committee.
I do sign things, but I'm not working on anything in particular that does that. However, I will present one idea, and it's one that I think the students should know about. And I learned about this from a really terrific engineer or scientist, Manu Prakash, who's at Stanford.
Yes, I know.
And
His work.
did the foldoscope. He's
Yeah.
done a number of it. But we had a very nice conversation in December. And he's very interested in climate and
I see.
looking at things in climate. And in the course of the conversation, those of us in the biological sciences have said to anyone that would listen over the years that if people are really interested in trying to cope with or even cure a disease, just studying the disease is too narrow-minded. You need to understand the basic science, and you'll never really know what basic science is going to be applicable until you actually know it. So getting the broad understanding is very, very important. There was actually a wonderful article written in 1939 by a guy, Abraham Flexner, who started the Princeton Institute for Advanced Study, who wrote an article called "The Usefulness of Useless Knowledge" and basic research, and it was a quite wonderful article. But we've said this now for a lot of time, a long time, about illness, about health issues. That we cannot. Yes, you need people that are directly working on Alzheimer's or cancer or this or that or the other, but you also need to have people understanding the basic underlying biology to give us new insights, new approaches, new ways of looking at things. It's absolutely essential. What we know now is not sufficient. And when I talked with Manu, he brought up the very interesting point. The same issue is a problem with climate science or climate mitigation. We turn on the radio or television and we basically hear people talking about how we're going to sequester carbon dioxide or how we're going to stop power plants from emitting this, that, or the other thing. Or we're going to have electric vehicles, all of which are important. All of these are addressing the problem. But Manu pointed out, we don't understand the basic cellular, molecular biology of how the oceans deal with carbon. How the planet actually works in these green, because we haven't looked in this way. He says there's a whole series of problems that basic science problems that we do not understand. And it's just like the medical example. It's not the direct, I'm going to do this and it's going to solve this. It's, we don't understand this system. We have to understand the system, and maybe some of that understanding is going to lead us to a completely new way of addressing this thing that we're really trying to address in all these other ways. So it's not that you give up medicine and only do basic research. You got to do both at the same time. It's not that you don't try to help the patients, but if you stop the basic research there's going to be no new approaches. There's not going to be CRISPR-Cas9.
Yeah.
There's not going to be all these other things that are new ways of looking at light super resolution microscopy. It just is an enormous list of things that one can look at that we haven't imagined yet, and yet the applicability is enormous. And so I was really taken by this idea, and I think that more and more people should be sort of talking about that this is not an engineering problem. This is not just an economic problem. This is a basic science problem. A basic understanding about how the world works, how the world copes with chemicals and everything. We really should be taking a much broader view. So I'm sort
Sure, I
of
will
a convert of that.
Yeah.
That's the idea. I think that I have not, other than talking with Manu about this, I have not heard anyone sort of bring up that point. So
I'll
in
try to-
situations like this, I try to convey that this is an important approach more generally. But we'll see what happens. Anyway,
Good.
Thank you for coming by. Thank
Thank
you
you,
for
sir.
the books. And
Yeah.